Okay, module 14, routing concept. So this module will explain how routers, yeah, 1 second. Okay, how routers use information in packet to make forwarding decision. Okay, we have subtopic path determination, packet forwarding, basic router configuration, IP routing, and static and dynamic routing. Okay, 14.1 path determination. So two function of the router. When router receive IP packet on one of the interface, it determines which interface to use to forward the packet to the destination. This is known as routing. The interface that the router use to forward the packet may be the final decision, or it may be a network connected to another router that is used to reach the destination network. So each network that a router connects to typically require a separate interface, but this may not always be the case. The primary function of a router are to determine the best path to forward packet based on the information in its routing table and to forward packet towards their destination. Router function example. The router uses its IP routing table to determine which path or route to use to forward a packet. R1 and R2 will use their respective IP routing table to first determine the best path and then forward the packet. All right. Okay, best path equal longest match. The best path in the routing table is also known as the longest match. The routing table contains route entries consisting of prefix network address and prefix length. For there to be a match between the destination IP address of a packet and a route in the routing table, a minimum number of far left bits must match between the IP address of the packet and the router in the routing table. The prefix length of the route in the routing table is used to determine the minimum number of far left bits that must match. The longest match is the route or route in the routing table that has the greatest number of far left matching bits with the destination IP address of the packet. The longest match is always the preferred route. The next prefix length will be used to refer the network portion of both IPv4 and IPv6 addresses. IPv4 longest match example. In the table below here, an IPv4 packet has the destination IPv4 address 172.16.0.10. So the router has three route entries in its IPv4 routing table, that match this packet, which is 172.16.0.0/12 and 172.16.0.0/18 and 172.16.0.0/26. Or the three routers, of the three routes, which is 172.16.0.0/26 has the longest match and will be chosen to forward the packet. For any of these routes to be considered a match, there must be at least the number of matching bits indicated by the subnet mask of the route. Okay, so like this example here, okay. So IPv6 longest match example. IPv6 packet has the destination IPv6. This one, 2001 DB8 C000 and 90. Okay. This example, entry, but only two of them are valid match, with one of those being the longest match. The first two root entries have a prefix length that have the required number of matching bits as indicated by the prefix length. The third root entry is not a match because it's /64. Okay, 64 prefix requires 64 matching bits. Okay, all right. So build the routing table. Directly connected networks. Added to the routing table when a local interface is configured with an IP address and subnet mask, which is prefix length and is active up and up. Yeah, both. Okay, remote network. Networks that are not directly connected to the router. Router learns about remote network in two ways. First, static, and also second is dynamic routing protocol. So static routes, yeah, added to the routing table when a route is configured. Dynamic routing protocol added the routing table when routing protocol dynamically learn about the remote networks. For the default route, yeah, default route, specific a next hop router to use when the routing table does not contain a specific route that matches the destination IP address. The default route can be entered manually or a static route or learned automatically from a dynamic routing protocol. So a default route has a 0/0 prefix length. This means that no bits needs to match the destination IP address for this route entry to be used. If there are no routes with a match longer than 0, the default route is used to forward the packet. The default route is sometimes referred to as a gateway of last resort. 14.2 packet forwarding. So packet forwarding decision process. First, the data link frame with an encapsulated IP packet arrive on the ingress interface. Okay, so next, the router examine the destination IP address in the packet header and consults its IP routing table. So third, number 3. Okay, next step. So the router find the longest matching prefix in the routing table. Next, number 4, the router encapsulates the packet in a data link frame and forward it out the egress interface. The destination could be a device connected to the network or a next hop router. 5, however, there is no match or no matching route entry, the packet is dropped. Okay, that's the process. After a router has determined the best path, it could do the following. Either forward the packet to a device on directly connected networks. If the route entry indicates that the egress interface is a directly connected network, the packet can forward it directly to the destination device. Typically, this is an Ethernet LAN. To encapsulate the packet in the Ethernet frame, the router needs to determine the destination MAC address associated with the destination IP address of the packet. The process varies based on whether the packet is an IPv4 or IPv6 packet. After a router has determined the best path, it could do the following. So forward the packet to a next hop. If the route entry indicates that the IP address is on the remote network, meaning a device or network that is not directly connected, the packet must be forwarded to the next hop router. The next hop address is indicated in the route entry. If the forwarding router and the next hop router are on the Ethernet network, a similar process ARP and ICMP-v6 never discovery will occur for determining the destination MAC address of the packet as described previously. The difference is that the router will search for IP address of the next hop router in its ARP table or neighbor cache instead of the destination IP address of the packet. Note this process will vary for other types of layer 2 networks. After a router has determined the best path, it could do the following. Drop the packet. No match in routing table. If there is no match between the destination IP address and a prefix in the routing table, and if there is no default route, the packet will be dropped. End-to-end packet forwarding. The primary responsibility of the packet forwarding function is to encapsulate packet in the appropriate data link frame type for the outgoing interface. For example, the data link frame format for a serial link could be point-to-point or TPP protocol, high-level data link control HDLC protocol, or some other layer 2 protocol. Packet forwarding mechanism. The primary responsibility of the packet forwarding function is to encapsulate packet in the appropriate data link frame type or the outgoing interface. The more efficiently a router can perform this task, the faster packet can be forwarded by the router. So routers should support the following three packet forwarding mechanism: process switching, fast switching, and CAF or Cisco Express forwarding. Packet forwarding mechanism. So process switching, So it is an older packet forwarding mechanism still available for Cisco router. When a packet on an interface, it is forwarded to the control plane where the CPU matches the destination address with an entry in its routing table, and then determine the exit interface and forward the packet. It is important to understand that the router does this for every packet, even if the destination is the same for a stream of packet. Fast switching, another older packet forwarding mechanism which was the successor to process switching. Fast switching uses a fast switching cache to store next hop information. When a packet arrives on an interface, it is forwarded to the control plane where the CPU searches for a match in the fast switching cache. If it is not there, it is process switch and forwarded to the exit interface. The flow information of the packet is then stored in the fast switching cache. If another packet going to the same destination arrive on interface, the next hop information in the cache is reused without intervention. Cisco Express Forwarding, CEF. The most recent and default Cisco IOS packet forwarding mechanism, CEF, built a forwarding information based FIB and an adjacent table. So the table entries are not pack triggered like fast switching but change trigger. such as when something changes in the network topology, when a network has converged, the FBI or forwarding base and adjacency table contain all the information that a router will have to consider when forwarding a cable. 14.3 Basic Router Configuration Review. Topology. The topology in the figure will be used for configuration and verification example. It will also be used in the next topic to discuss with the IP routing table. Yeah. Okay, configuration command. Okay, you can see here, this all the configuration has been made. Yeah, in the config is teach you how to go from the configure terminal. You have to put this, enable and configure terminal. Appear here, just set all the details, and here this is how you're going to setting all the interface. All right. So verification command. Common verification command include the following: show IP interface brief, show running config interface, show interface, show IP interface, show IP route, and also finally, which is ping. In each case, replace IP with IPv6 for the IPv6 version of the same thing. Okay, filter command output. Filtering command can be used to display specific section of output. Yeah. To enable the filtering command, either a pipe, okay, this symbol they call a pipe, character after the show command, and then enter a filtering parameter and filtering expression. The filtering parameter that could be configured after the pipe include section, which is display the entire section that starts with the filtering expression. Second, include. This include all output line that match the filtering expression. Third, exclude. This exclude all output line that match the filtering expression. Begins. This display all the output line from a certain point, starting with the line that match the filtering expression. So output filter can be used in combination with any show command. Packet tracer. So this packet tracer will help you to understand the basic configuration of router. Yeah. In this packet, you will do the following. First, configure devices and verify connectivity. And last or second task is to display router information. Okay. You can have this packet tracer in our NetAcad website. Yeah. 14.4 IP routing table. Root sources. A routing table contains a list of routes to known network prefix and also prefix length. The source of this information is derived from the following, which is direct connected router, static, and also dynamic routing protocol. The source for each route in the routing table is identified by a code. Common code including the following: L for identifies, the address assigned to a router interface. C identify as directly connected. S identify a static route created to reach a specific network. 0 identify a dynamically led network from another router use the OSPF routing protocol. So this route is a candidate for a default route. Routing table principle. There are 3 routing table principles as described in the table. Though these are issues that are addressed by the proper configuration of dynamic routing protocol or static routes on all the routers between the source and destination devices. Routing table principle. Every router makes its decision alone based on the information it has in its own routing table. For example, R1 can only forward packet using its own routing table. R1 does not know what routes are in the routing table or other routes, example for R2. Okay, the information in a routing table of one router does not necessarily match the routing table of another router just because R1 has a route in its routing table to a network in the internet via R2. That does not mean that R2 knows about the same network. And then next, routing information about a path does not provide return routing information. R1 receive a packet with the destination IP address of PC1 and the source IP address of PC3. Just because R1 knows to forward the packet out its interface, which is G000, does not necessarily mean that it knows how to forward packet originating from PC1 back to the remote network of PC3. Okay, routing table entry. In the figure, the numbers identify the following information. Route source. This identify how the route was learned. Second, destination network. Prefix and prefix length. This identify the address of the remote network. Next, administrative distance. This identify the trustworthiness of the root source. Lower value indicate prefer root source. Metric. This identify the value assigned to reach the remote network. Lower value indicate preferred routes. Next hop. This identify the IP address of the next router to which the packet will be forwarded. Route timestamp. This identify how much time has passed since the route was learned. And then for exit interface, this identify the egress interface to use for outgoing packet to reach their final destination. Note, the prefix length of the destination network specify the network minimum of far left bits that are matched between IP address of the packet and the destination network prefix for this rule to be used. Okay. Directly connected network. To learn about any remote network, the router must have at least one active interface configured with an IP address and subnet mask prefix line. This is known as a directly connected network or a directly connected route. Routers add a directly connected value route when it route to its routing table when an interface is configured with IP address and is activated. A direct network is denoted by the status code of seed in the routing table. The route contains the network prefix and prefix length. The routing table also contains a local route for each of its directly connected network indicated by the status code of L. For local routes, the prefix length is /32, and for the IPv6 local route, the prefix length is /128. This means the destination IP address of the packet must match all the bits in the local route for this route to be a match. The purpose of the local route is to efficiently determine when it receives a packet for the interface instead of packet that needs to be forwarded. Static routes. After directly connected interface are configured and added to the routing table, static or dynamic routing can be implemented for accessing remote network. Static routes are manually configured. They define an explicit path between two networking devices. They are not automatically updated and must be manually reconfigured if the network topology changes. Static route has three primary uses. First, it provides ease of routing table maintenance in smaller networks that are not expected to grow significantly. It uses a single default route to represent a path to any network that does not have a more specific match with destination route in the routing table. Default routes are used to send traffic to any destination beyond the next upstream router. It routes to and from stub network. A stub network is a network accessed by a single route, and the router has only one neighbor. Static route in the IP routing table. The topology in the figure is simplified to show only one LAN attached to each other. The figure shows one IPv4 and IPv6 static route configured on R1 0.0.4.0/24 and 2001 DB8 ACAD, ACAD 4/64 network on R2. Dynamic routing protocol. Dynamic routing are used by routers to automatically share information about the reachability and status of remote network. Dynamic routing protocol perform several activities, including network discovery and maintaining routing tables. Dynamic routes in the routing table. OSPF is now being used in our sample technology to dynamically learn all the networks connected to R1 and R2. The routing table entry use the status code of 0 to indicate the route has learned, was learned by the SPF routing table. Both entry also include the IP address of the next hop via IP address. IPv6 routing protocol use the link local address of the next hop router. Note SPF routing configuration for IPv4 and IPv6 is beyond the scope of this course. The default route, specify a network next hop router to use when the routing table does not contain a specific route that matches the destination IP address. A default route can be either a static route or learn automatically from a dynamic routing table. The default route has an IPv4 entry, IPv4 route entry of 0000/0 or an IPv6 route entry of /0. This one. This means that 0 or no bit need to match between the destination IP address and the default route. Structure on IPv4 routing table. Okay.